In the observable universe, with a diameter of 93 billion light-years, astronomers have discovered hundreds of billions of galaxies. In most people's imagination, hundreds of billions of galaxies must be densely packed, filling the entire universe. But in reality, there are still many galaxies in the universe, regions with extremely sparse distribution. Such cosmic spaces are generally called voids. At a distance of 700 million light-years from Earth, there is a space-time region with a diameter of 330 million light-years. It is called the Boötes void. The reason for saying this is because that astronomers have only found 60 galaxies here, while in other parts of the universe, in the same size space, there are at least 10,000 galaxies. Apart from their small number, the 60 galaxies in the Boötes void, distances are still over 10 million light-years. In comparison, the Milky Way and the neighboring Andromeda galaxy are separated by only 2.2 million light-years. Based on the above data, if galaxies in the Boötes void if intelligent civilizations exist, their astronomers would most likely believe that there is only one galaxy in the universe, their own. And if the Milky Way were located in the center of the Boötes void, then humanity would not have discovered any extragalactic systems before 1960. Besides the Boötes void, in 2007, American astronomers, there is also one in the constellation Eridanus, southwest of Orion, discovered a new void. This Eridanus void, located 6 to 10 billion light-years from Earth, with a length of 500 million to 1 billion light-years, is also not completely empty inside, but like the previous Boötes void, contains several galaxies. From the current cosmic microwave background radiation map, deep blue cold spots in the universe almost all belong to giant voids, because photons, only when passing through regions of extremely low matter density, will lose energy, thereby appearing on the cosmic microwave background radiation map, leaving cold spots. But why do so many voids appear? In cosmology, there is a concept called homogeneity, which generally means that when observing from Earth in all directions, we can see roughly the same number of galaxies, uniformly distributed throughout the universe. Hubble telescope's successive deep field photographs also confirms this point. But in fact, the Hubble telescope's deep space photos are just long exposures of a small patch of the entire sky, while radio telescopes surveying the entire sky, the images obtained indicate that all matter is not randomly and uniformly distributed. Galaxies are affected by gravitational forces on large scales, forming filament-like structures, and then with superclusters as nodes, constituting the cosmic web structure. On the cosmic web, second in scale only to the observable universe, filaments are called cosmic walls, while the empty regions between filaments are cosmic voids. Current scientific consensus holds that observable baryonic matter accounts for only 4.9%, with dark matter at 26.8% and dark energy at 68.3% are the mainstream of the universe. Among these, dark matter provides additional gravity for galaxies, ensuring they don't fall apart. Dark energy counteracts gravity on large scales, causing the universe to accelerate its expansion. But for galaxies and galaxy clusters, whether the universe itself expands or not does not quickly affect them. Only gravity can truly determine the fate of celestial systems. 13.82 billion years ago, after the Big Bang, symmetry breaking prevented matter and antimatter from complete annihilation. This led to the material universe we have today, and matter is governed by gravity. Gravity causes hydrogen to condense into stars, and stars to gather into galaxies. Galaxies, under the influence of cosmic expansion and dark matter, becoming connecting bonds, ultimately forming the cosmic web we see today. The formation of the cosmic web is essentially because ordinary matter cannot fill the entire universe. After all, in the face of dark matter and dark energy, ordinary matter at 4.9% can only be dominated, and unable to actively shape the appearance of the universe, much like using photos of Andromeda to represent the Milky Way in early promotions. Today's Boötes void. It is also often confused with Barnard 68 Nebula online, because Barnard 68 is a dark nebula. Its appearance matches the description of cosmic voids very well. But in reality, Barnard 68 is only 400 light-years from Earth, and the actual dark region has a diameter of only 0.5 light-years, not even in the same order of magnitude as the Boötes void.